Hi everyone, I'm Jason Wu, a third-year PhD student from the HCI Institute at Carnegie Mellon, and I'm happy to be here today to present a project that I worked on with my collaborators at Apple called When Can Accessibility Help? An exploration of accessibility feature recommendation on mobile devices. So I'd like to start out by asking you to imagine that you're having trouble seeing some text or content on your phone. What would you do? How many of you know where to find relevant display settings and how to change them? What if instead you had trouble hearing some media or found it difficult to perform certain gestures on your phone? Would you think of checking for existing features or settings that could help? I'm guessing since we're at an accessibility conference, you might have a better idea than most people, but we ran a study where we asked 100 people online ages 18 and older a set of similar questions designed to measure their awareness and knowledge of accessibility features on smartphones. And we wanted to know two things. One, would users think to check their phones for existing solutions if they developed an accessibility need? And two, do users know how to configure their devices to better support those needs? So you can't just ask people if they know about a feature because that would give it away. So we asked our questions in stages. We first asked them similar hypothetical questions to the one I just asked you about what they would do in certain scenarios. And later we asked them more specific questions that were targeted around certain features, like for example, how can you configure your phone to make content larger and easier to view, as a question for font size. And as it turns out, for both of our research questions, the answer was no. Only around 15% of participants mentioned checking or using things on their phone, and only around 10% of responses included the best setting or a rough equivalent. And later, we asked a similar set of questions to a group of 20 older adults, and awareness was even lower. And this is despite older adults them being more likely to actually develop accessibility needs and actually benefit from these features. So finally, we asked both groups if they even knew what the term accessibility meant, and only around 18% of people in our survey answered correctly, while only 10% of older adults knew. So what did this tell us besides the fact that a lot of people aren't aware of accessibility? Well, many users might just be getting by using their phone under suboptimal conditions. So what I mean by this is, so for example, someone who found content too small could still, quote unquote, get by using their device by bringing the phone closer to their face or by squinting at the screen. And as developers, we could think about detecting these usage behaviors and proactively surfacing helpful features. So this isn't just limited to text size or content size. Through decades of accessibility research and development, modern smartphone OSs like iOS contain many accessibility features, with iOS having over 50 at this point. So this suggests that in addition to spending effort on developing and refining new access technology, we should also spend some effort matching this technology to people who could benefit but might not know about them. So we took this idea and applied it to many of the features available on smartphones right now. And here's a table listing out some potential approaches for common features. So it's important to note that our approach can't recommend all features. For example, ones that would require external hardware, or for example, it can't recommend a screen reader to someone who is blind, because one of our assumptions is that a user has to be able to use a device for us in order for us to make recommendations. But many are compatible, and we came up with four main methods, which we call detection strategies, of inferring when we might want to recommend them to users. And I'll talk about those now. So one way we thought of recommending features was along the lines of traditional recommender systems, which operate under mainly operate under the assumption that someone who likes certain things will like similar things. And one of the assumptions of this project is that users often don't have any accessibility features turned on because they don't know about them. And in this case, there wouldn't even be enough data for a first recommendation. However, we found a similar idea could be useful when used along with other strategies that I'll talk about later. And the idea is to first recommend features using other detection strategies, then gradually expand awareness to new features through what we call a grouped detection strategy. And we implemented simple rule-based groupings that recommend related features that might not appear close to each other in the settings menu, but would be useful if used in conjunction. An example of this could be recommending the type to Siri feature if a user uses a hearing aid or has other hearing related features enabled. As I mentioned earlier, one way we might think about recommending font size and other content enlargement features is by detecting if a user is holding their phone consistently very close or very far from their face. And we call this approach statistical detection, as it might measure something like reading distance and check if that's within some expected bounds. So we use this approach for font size by tracking the face with ARKit and recommending, and we could also use this for recommending subtitles and captioning if the volume of media is consistently set very high. So some interactions on your phone might use some kind of threshold. For example, iPhones might ask you to double click the side button to open the Apple Wallet or confirm a purchase. And by default, these thresholds might be inaccessible to people with motor impairments because they can't double click quickly enough for the phone to register that gesture. So what we did was we monitored interaction logs for these kinds of near misses that would have triggered under another slower threshold that is adjustable in the settings. And finally, in some instances, a strong connection is known between a specific sequence of behaviors and a feature that might be useful. Often this behavior is kind of a workaround or a less effective way of doing something that is better supported by an accessibility feature. As an example, the magnifier in iOS allows users to use their phone's camera as a magnifier and zoom in on things that are hard to see around them. And people who don't know about this might take a picture of something using the camera app, open that in a photo viewer, and then try and pinch to zoom or manually zoom into that photo. And so using this framework of detection strategies, we built several prototype recommenders for different accessibility categories, which I'll kind of show and describe now. The first is a font size. The first is a font size and zoom recommender that detects if you consistently hold the phone close to your face, and it'll send you a notification that says, "Did you know that you could change the font size?" And when you click on it, it'll bring you to the location settings. It also comes with the home screen widget. We made a subtitle and captioning recommender that is based on a similar principle and notifies you if you're consistently listening with a loud volume. This is a video of our detection app for the side button click speed. So it'll monitor and recommend a threshold based on your double clicking speed. And finally, this is an app that detects if you're using VoiceOver to interact with it and recommends audio descriptions if it's not enabled. So in building these prototypes, we also thought a little bit about some of the trade-offs someone might encounter in implementing these. So for example, looking at different ways that recommendations could be surfaced, a pop-up might be able to more directly notify users of a feature. But from what we know about things like sticky keys, it might also be seen as intrusive or annoying. On the other hand, a home screen widget or a search recommendation might be a more subtle way of surfacing recommendations, but it also decreases the likelihood that users will actually discover and adopt the feature. So to understand some of users' preferences around feature recommendations, and also to get an idea of how useful they might be, we conducted a user study with 20 older adults. One person actually withdrew due to difficulty using the phone, so we just report on the data from the other 19. And in this study, we gave people a smartphone configured to collect some of that usage data and asked them to perform a set of tasks such as browsing the web, watching a video, and installing apps. And afterwards, in an interview, we showed each participant some accessibility features and asked them to rate how useful they thought that feature was. And in total, our detection strategies detected 19 times where a recommendation could be surfaced. And from participants' feedback, they would have found most of them useful. So for those that they didn't see as useful, we asked them why, and they could often be attributed to personal preference. For example, one person consistently had the volume set very loudly, and when we asked why he didn't think captions were useful, he said that when he watches TV with closed captioning, he finds the extra text distracting. And on the other hand, sometimes people would find features useful that weren't triggered. So as an example, one person didn't hold the phone particularly closely during the usage study, but still noted that making content larger would be helpful for reducing eye strain and making things easier to read. So beyond the performance of our detection strategies, what this feedback shows is the importance of understanding context and user preference when making recommendations. 90% of users felt that recommendations of accessibility features would be useful, and most preferred low frequency surfacing methods that didn't interrupt the current task. So this quote kind of sums it up, where one participant said, "If there's something that could help me use my device, then I want to know about it." But not everyone wanted to receive them. One of them said, "I might find it confusing." And another said, "Not necessarily. Once I learn how to do something, I'll be set in my ways." So I think future research in this area would benefit from understanding and accommodating some of these additional factors that affect the perception of recommenders and the utility of their recommendations. So in conclusion, in our work, we first showed that most people don't know about and don't know how to use accessibility features that are already available on their phones. And this is especially true for older adults who might be more likely to benefit from them. In addressing this, we focused on the idea of recommending accessibility as a way of surfacing potentially useful features and increasing overall awareness. We introduced several detection strategies that cover a large number of features currently available on smartphones and implemented a subset of these as prototype recommenders. And finally, using these as design probes in a population of 20 older adults, we got promising initial feedback showing that older adults are likely to appreciate and benefit from accessibility recommendation. So with that, I'd like to thank my collaborators on this project. And if you have any questions or comments, feel free to contact me by email. Thanks.